Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. Every week on Tuesdays, although we've had a bit of a break, we're just starting back up again, we do a session for beginner programmers who are wanting to use Python and to learn about machine learning. I'll do the sessions on standard Python, and Arun Prakash does the sessions on machine learning. Today, because it's the first week of the month, on the first week of the month we do a session for absolute beginners. So it's people who haven't seen any Python before, and we've had a lot of people register for this session. So I hope that you all find it useful. During the session you can ask questions. I'll be listening on the YouTube chat, so you can type in a question there, and I'll also be monitoring the Slack channel, which is our Beginners Python and Machine Learning channel, Learning to Code. So if you have any questions, you can ask in either of those places. Today we're going to be using Google Colab for Python. There's several ways to use Python, but this is a very good way for absolute beginners because you don't have to worry about installing anything. And it's actually quite a powerful tool. I know people have been programming in Python for years and they're still using Google Colab because it gives them everything that they need. Now I've put in the description for the YouTube video and also in the description for the meetup a link to Colab research at Google, and there's a notebook there that you can get a copy of. So if you click on that link, it will open up a copy of my notebook. So let me know if you have any problems clicking on the link and bringing up this notebook. And the first thing you'll want to do is copy it to your drive. To do this, you'll actually need a Google account. So I put in the notes beforehand that it would be good if you've got a Google account. So yeah, hopefully you've got one of those already, and you can do this in standard Python, or you can run Jupyter notebooks on your computer, but they're just a lot harder to set up. The first thing you want to do is copy this notebook to your drive, so then you can make changes and save changes. So I'll click on this copy to drive link here, and that creates a copy of the notebook. You see it's now got the word copy of Meetup 109, and it's I can now save this one in my account. Now as we go through tonight's session, I will be making changes to this notebook, so you can open a copy of this one, which has got will have the changes in it. You can have that in another tab, and you can just refresh it and it'll show anything that I've typed will come through to it. Change link, anyone on the internet. So I'll copy this link and I'll paste this into YouTube chat and into the Slack meetup, the Slack channel. All right. I see Arun's pasted the link to the YouTube video, so it's good. Arun's watching as well, so if you've got any questions you can ask them on Slack and Arun will answer, or I'll answer. Okay, so what is this Google Colab? It's a mixture of cells. Each one of the cells got a rectangle around it, and each cell can be either a text cell or a code cell. So these ones, which is just description, they're text cells, and then we get down to here, so they're still just text cells, and the code cells have got a little play button so you can run what is in the cell. At any time you can add in extra cells if you want. You can click, I want to add a code cell, it'll just add one above here, or add a text cell, and there's some tools and menu items up here of things to do. It's often useful to look in keyboard shortcuts to have a look at all the keyboard shortcuts. I'll tell you the ones that I use, but there's quite a lot that can help you get around inside a Google Colab notebook. So the first thing I'll show you how to do is how to get help when you're in the Google Colab notebook, and that's you can press a question mark. So we've typed the question mark here. These are just comments with the hash signs at the front, so they don't do anything. And then the question mark shows you how to get help. So if we run that cell, and we can do this either by pressing Control Enter or pressing the play button there. And the very first time you run a Google Colab cell, you're going to find that it's a bit slow. It's got to start up a whole environment for you to use, and then it will continue to work. And here we go. Here's the help on how to use Ipython. All right, so Ipython is interactive Python, and there's various forms of Ipython. There's Google Colab, there's Jupyter Notebooks, and they're both very similar. Ipython is Jupyter Notebooks came out of Ipython. There's other ways of running interactive Python, such as Python console, and then the other way of running Python is through scripts. So you can run Python scripts, and that just uses standard Python. Interactive Python is great because you get immediate feedback, and so it's much faster to learn on this. And you can, I use it even when I'm writing programs. I jump into Python console or Ipython all the time to check out some lines of code, see what effect they have, and then I put them into my real code. Coding is all about writing commands for your computer, and the computer follows them one at a time. So, for example, if we want to display a number, the number 5, we have a command print 5. So prints the command, and what we want to print is number 5. So if I do Control Enter now, it runs that and it displays a 5 for us. Now that'll work in Python and in Ipython. If you are running Ipython or Python console, you can you don't even need the print. You can just put the value that you want it to display. I've just put a 4 there, and it'll now display a 4. So you can do this in the notebook that you've got, and run these things. You can even add in an extra cell if you want to try something. So like I press add a code cell in here. I want to see what happens if I type 3, and it displays a 3 for me. So give that a go. Try these out as we're going along, and you'll learn a lot more quickly. If you've got more than one command, it will run through them sequentially. So here we've got 2 commands, print 4 and print 3. And if we run that by Control Enter, see it prints the 4, and then on the next line it prints the 3. So this is one way of doing it. The other way, you think you could try doing 2 and then 1, but Ipython only looks at the last value in this sort of scenario, so you'll only see the 1 coming. So if you want to do more than 1, use the print. I'll probably use print most of the time, but if you are doing it yourself, you can take shortcuts and not put the word print around. Alright, so we've learned a little bit about programming here, and we're going to have a task. So in the empty cell below, we're going to write our first Python program. So you can have a go at this. If you want, you can pause the video and then catch up to us later, or have a go while I'm doing it. I'm going to show how to write the solution, and then I've got an actual solution that we can look at and compare my solution with a provided solution and see what we can learn from that. So we've learned that to print a number, we use a print function, and in the parentheses we put what we want to print. Now we want to do from 5 to 0. So I can put in 6 print statements, and do Control Enter, and it prints the numbers 543210. So that's the solution to the task, and if you want to grab that solution, remember if you've used that link that I've shared, you can see what I've typed. You can bring up what I've typed, so you don't have to type it all yourself. Okay, so let's have a look at solution that's provided, solution 1. And it looks a little bit different, so let's run it and see what it looks like when we run this one. So it says solution 1 counting, and then it does the 543210, and it prints the numbers in as words rather than as digits. And so how does it done that? You can see what's different. It's put the letters in here, but it's also put these double quotation marks around them, and that's how you work with strings of text in Python. You can put double quotes around them, or in fact you could use single quotes if you wanted, and there's a couple of other ways of doing quotes, but that's if you want to do text, that's how you do it. So feel free to ask any questions as we're going along, if there's something you don't understand. And remember, it's absolute beginners, so it can be anything about how to get started. Alright, so we've used the print function here to display results. We can also use another function called type that will show us how what the type of a value is, what the data type is. So if I put my string of text here in quotation marks, and they say what is the type of that, and it'll tell me it's a string. And remember, before we were just doing digits, and if I look at the type of that, they tell me that's an int, which stands for integer. So that's like a whole number, so either positive or negative, but it doesn't have any fractions. So what if we do have some fractions? We can put in a decimal point, or 123.45. What's the type of that? And Python works out that that's a floating point number. So at any time, remember, you can just throw in. I find this one quite a useful thing to check, is what's the type of a value that I've got as a result of calling a function, because it's Python is dynamically typed, so any variable can be of any type. So for example, if I wanted to know what the type of 3 plus 4j is, and this is actually another sort of number that Python can use, and the type of that is a complex number. So j is actually the square root of -1. So people who like doing complex number arithmetic, they can do that in Python as well, just using some of its native types. Python can do arithmetic on numbers, and these are the operators. So you've got the plus, the dash, the asterisk, the slash. So this is addition, subtraction, multiplication. If you're doing a single slash, that's floating point division. If you do a double slash, that's integer division. Percent is the remainder after integer division, and star is to the power of. So I went through most of those in Getting Started 1, but still feel free to ask any questions about these if you want. So here you go, 1 times 2 plus 3 times 4. You can see it's worked out the order of operations. 1 times 2 is 2, 3 times 4 is 12, so multiplication comes before addition, and then it's added 2 plus 12 to give you 14. So it makes a good little calculator here. You can just type in any expression and it'll calculate the result for you. The results, you can save those results if you want. You save them in memory, and the way you do that is you give them a name, and that name is called a variable, because you can change the value in that name, and it's going to be, it just saves the value. So for example, if I said a equals 5, it takes the value 5, stores it in memory location that we're going to call a, and then I can print out what's in a, and it'll tell me that that's got a 5 in there. And so for example, I could do B, I want to store 2 to the 32nd. C, I can now do arithmetic based on using variables rather than the literal values that we were using before. So that'll be 5 times 2 to the 32nds, and we'll store the result in C. Then I can print it. I'm using a different version of the print function here. You see I've put 3 values and they're separated by commas, and it'll print out each of the 3 variable values. So A is 5, B is 4 billion, and C is 21 billion. Okay, programming would be very cumbersome if we had to type a line for every command we wanted to execute. So we can repeat some commands by putting them in a loop. Loops in Python, they start with the word while or the word for, and the commands that are going to be repeated inside the loop are indented. So that's how Python knows which part is going to be repeated. And that's all the indented part of code is called a code block. So what you'll find in a Python statement, you'll have a colon at the end, means the next line is going to start a code block. And then you see the indentation here, 4 spaces. It can be anything that's consistent. It can be a tab. It can be 2 spaces. If you're using Google Colab from scratch, you might find that it defaults to 2 spaces as the indentation when you press tab. I've configured it for 4 spaces because that's more common in the Python world. So it'll loop through these 2 commands and then go back and then do those 2 over and over again. And as it goes through the loop, we've put here a sequence of values. We've got 6 values there, and each time we go through the loop, it stores the next value into this variable. So we've got a variable Z, it's a memory location, and the first time through this loop, the number 5 will be put into that variable, and we run through the loop. Then the next time through the loop, the number 4 will be put into Z, and it runs through the loop again. So if we run this bit of code here, Control Enter, you can see it's prints 5, then prints 4, then prints 3, prints 2, and every time it does that, it uses this notation here, total plus equals Z, to add to whatever was the previous value of total with what the current value of Z is. So total started off as 0, and then added 5, then 4, then 3, then 2, then 1, then 0. And then we can print out the total of all the above numbers, which is 15. And you see how this print statement is not indented, so that's outside the loop. So it only gets run once the loop is completed, and it only gets run once. Okay, Andrew Sturgis says that he got lost. I hope other people aren't lost. The links that I was showing you, and you can always remember that even though you're watching this live, you can rewind the video or pause the video to watch it. And then what I often do in these situations, if I'm watching someone else present live, I'll pause the video, work out what they've done, and then I'll start playing at single speed or 1.5 speed if I'm understanding what's going on, and that way I can catch up to them being live again. So here's a link in the meetup description that takes you to the Colab, and the other one is the that link should also be on the YouTube video in the comments section at the description section at the beginning of the video. In the chat, I've also sent you a link to the to the one that I'm working on, which is called copy of meetup. And if you like, that's the only one you need to use. You can just grab that one and even take a copy of that. So you'll have copy of meetup 109 coding introduction, and then start working through that. So, but let me know if I'm going too fast. And I'm happy to go over anything again. Okay, so task 2, rewrite the loop to show a running total as it loops through all the numbers. So we click into the cell. It's a code cell that's been left there for you to do this. And we're going to do exactly the same code, so I'm just going to copy and paste. And we want a running total, so we're just going to print 2 numbers, so we can separate them by commas. And then when we run that, we can see our Z goes 543210, and the running total is 5, 9, 12, 14, 15, 15. Okay, so we'll look at the provided solution, and the provided solution is showing you how to use the while loop rather than the for loop. So remember, for loop has the for loop has got a list or a sequence of values here, and each time through the loop it puts the new value into this variable. The while loop will just continue looping while some condition is true. And so this is called a condition. Z is a variable, greater than or equal to. Just tests whether Z is greater than or equal to 5. It's a 0. So the first time Z equals 5, so that'll be true. It'll do the loop, and then we subtract 1 from Z. So the next time Z value have changed, so we check it again to see whether that's still true. And if it's true, we'll run the loop again. In our print statement, as well as printing our number and our running total, we've put some text in there. So you can see number, and we've put quotation marks around it, so it knows not to look for a variable called number. It knows this is a string of text called number, string of text with the letters of number in it, and so that's what it'll display. And you can see here, number 5, running total 5. Good. Andrew Cox has said everything's perfect, so that's very good. Okay, task 3. Write a loop which counts up from 1 to 5 and displays the factorial of each number as it goes. And so the factorial is 1 times 2 times 3 up to the last value. Okay, so we know how to go from 1 to 5. 1, 2, 3, 4. Sorry. That's what we do know. We don't know about range, so I'll leave that out. And we're going to start off with our factorial. It's going to start off at 1, and times equals Z. So remember, we've done plus equals, now we can do times equals, and we'll print Z and the factorial of Z. So factorial of 1 is 1, factorial of 2 is 2, factorial of 3 is 6, factorial of 4 is 24, and factorial of 5 is 120. So how are you going with these little exercises? Are people able to work them out? Let's have a look at the solution here. Now the solution is using a range function. Because one of the problems in the solution I typed here is it doesn't scale very well. It doesn't work so well for big numbers. Like if I wanted to do 20, I'd have to do 1, 2, 3, 4, all the way up to 20. So Python provides a built-in function called range that will go from 1 up into a stop value. It goes up to, but not including the stop value, and so you can specify a long sequence like that with just a couple of numbers. And if you want to go up other than in ones, you can provide a step value as well. If you want to go up in 2s for whatever reason, or 3s, or if you wanted to count backwards, you use negative numbers there. Okay, so let's run this. And you see it goes all the way up to 19 because it goes up to but not including the last value. And the reason they do that is that's pretty much consistent all the way through Python, how they use things. They'll start at 0 if we don't specify. In this case, we've specified to start at 1. And they go up to, so they start with that number inclusive and that number exclusive. And that means that the number of numbers is always the second number minus the first number. So 20 minus 1, there's 19 values in that range. Okay, display the first 20 numbers in the Fibonacci sequence. So Fibonacci is a numerical sequence. It goes 1, 1, 2, 3, 5, 8, 13. And the formula that you use to get that, you start off with F1 is 1 and F2 equals 1, and then Fn is always Fn minus 1 plus Fn minus 2. So our F1 here is basically, let's call that n minus 1, and this one n minus 2. And we'll have F0 as the current number. All right, so display the first 20 numbers in the Fibonacci sequence. So we want to go through a loop 20 times. So now I know the range function. I can just say 20. Okay, I'm going to start off defining my variables. F1 equals 1, F2 equals 1. Okay, actually I'll go F3 equals F1 plus F2, and I want to print out, I'll just print out F1. So actually the way I'm doing this is F1 is going to be, for n equals 3, F1 is Fn minus 2, F2 is going to be F3 minus 1, and this is F3. Yep. So I'll print out F1. And then we have to, the next time through the loop, we're going to have to copy those values across. So if the second time through, F1 is going to equal what was previously F2, and F2 is going to equal what is now F3, and then we can do the loop. So let's try running that and see if we got it right. So we've got 1, 1, 2, 3, 5, 8, 13. Yeah, so that's the first bit of the loop. Looks all right. We've got 20 print statements because we went through the loop 20 times, and the last number is 6765. So, and I even did this all in the same cell as the task. So there's a cell we were supposed to do it in, but that doesn't matter. So let's have a look at the solution. Now there's a few things in here that shows a couple of new features of Python. So I'm just introducing them to you one at a time. So F1, F2 equals 1, 1. So we've saved gone from 2 lines of code here and done that all on 1 line. And that's actually quite a useful thing to do. It makes it clear what we're studying, and it just makes that code a bit shorter. Alright, and we go through the loop, and every time we go through the loop we say that our new F1 is our old F2, which is correct, and now our F2 is equal to what was F1 plus F2. You see how we needed a third variable here, F3, because we were just doing one assignment per line, but because we can do multiple assignments on one line, we don't need that variable anymore. So what it does is it calculates all the values on the right and then assigns them to all the values on the left, and then prints the results. Let's have a look at what it looks like. Okay, so this we've managed to print them all on one line, which is pretty clever, because a print statement here would normally print a new line at the end of each statement. So the way we've done that is when we've used the print function, we've added this parameter to the print function saying our end character, we don't want it to be a new line, we want it to be a space. And so it's printed the 1 and then left a space, then printed the 1, then left a space, then the 2 and left a space. And then finally at the end we've done print F1 comma F2, and this time we didn't specify the end, so it has put a new line, and therefore we can see all the results, and it's printed it on a new line. The other unusual thing here, this is a new thing here, for the variable name we applied a variable name up here, I, for I in range 20, but we didn't use that variable anywhere in the loop. And if you don't use it, you'll often find in Python programs people who use this variable name here, underscore, which basically says I'm not going to use this variable name, so I'm not going to save it anywhere. Okay, let's keep working on through the tasks. Task 5, count down in steps of 2.25 from 10.5 to -3 inclusively. Okay, so if I was thinking how to do that, I'd think maybe we can use the range function and start at 10.5, go down to -3, so let's go -4 because we want to go a bit further, and go down by 2.25 each time. But if I try running that, I'm going to get an error, and it's because the range function here only takes integers. So I can't use a for loop with a range function like this. So what I can do, I can use while for this situation. So let's try, Z's going to start off with a value of 10.5. While Z is greater than or equal to -3. Print Z, and then subtract 2.25 from it. And there we go, that works. So we've printed out 10.5, 8.25, all the way down to -3. So let's have a look at the solution. The solution has done this using the range, and the way it's done that is it's found the lowest common denominator is 4, and it's used integers throughout. So it's converted this floating point number into an integer, and then this -3 is not a floating point number, but anyway, we'll make sure it's definitely an integer after we've multiplied by the lowest common denominator, and 2.25 is floating point. So multiplying that by 4 and then making that an integer, we should be able to get integers all the way through there, and then we can use a for loop, and so then that it works. Showing a little bit more stuff here to get used to some of the things you can do with print statements. We've got we're putting some print formatting in here. So what we're going to print here is a format string. So we've put an F outside the double quotes. There's only a couple of letters that you can do outside double quotes here. So F means a format string. And then inside the double quotes, we put in these curly braces. And the curly braces mean evaluate anything inside it first and then print that. So x divided by the lowest common denominator. And then after the colon, we can actually put a format. We say we want it to be 7 characters wide. We want it to have decimal places. We want to have 2 decimal places. And the number is a floating point string. So there's a whole bunch of different formats. So going through all of them is beyond the scope of tonight's lesson, but I'll just introduce you to some of these formats. And you can see we've got a nice right-aligned list of numbers here. If you are trying to improve your report printing, then start looking into these format strings for what options you've got available. All right. Are people able to hear me? I've got a message saying the chat's been disconnected. But, oh no. I've sent something to chat, so let me know if people are still able to hear me. There's no network problem going on. All right. Now, floating point numbers. Oh, good. Peters can hear me. Floating point numbers are stored in binary in Python, and this can be a bit of a problem because decimal numbers can often not be represented exactly as a binary number. Now, these numbers I chose up here, they can be because they're all a multiple of a half, or a power of a half, but 0.1 is not. So if I was to run this, you can see I start at 1, I subtract 0.1, 0.1, and then every time I'm doing this, the error is accumulating and accumulating, and it finally gets to a value that it starts to display a different number than what we'd expect, and in fact doesn't get down to 0 exactly. It's 1 by 10 to the minus 16. So that's another reason for using integer arguments in a range, and it's something that you have to be aware of. So if we did a similar thing using a range with integers and then only dividing by 10 at the last minute, then we can see that error doesn't accumulate, and so it will display correctly. But just be aware of this. There are classes in Python if you really need to do exact decimal arithmetic. There's a class called decimal that allows you to do that. It's not quite as fast as floating point, but if you're doing accounting type applications, then you might find that that's a necessary class. All right, what are we looking at here? New data types. We've got the list data type. So previously we had a sequence of numbers we were putting in parentheses. This is a sequence of numbers put in square brackets. So if you put them in square brackets, that's called a list. And it's an ordered collection of any data values of any type. So we can print that list of values. So it just prints it out with the square brackets there. Now to create a list, you can start off with an empty list, which is just 2 square brackets, and then you can just append values to it. So what are we doing here? We're just putting in values that are 2 times x. So let's run through that list, creation, and then print the list, and you can see there's the list with all those numbers in it. Okay, rewrite the following code using nested loops. This is a little bit of a jump, but let's have a look at the code here. We've got printing. Let's run it and see what it looks like. So the code here is to have a look at different ways the range function works. So it prints what the range is, and then it prints what the values in that range function will evaluate to. Okay, now if you look at that code, it's fairly repetitive, although slightly different on each line. But it's really the functionality is the same. So we're trying to do the same sort of thing over and over again. Whenever you see that, you think, well, yes, I can probably put this into a loop. And the first time through the loop, we're looking at range 4. The second time through the loop, we're looking at range 2, 5. Third time, we're looking at range 3, 14, 4. So we can put all those values into a list and then loop through the elements of the list. So let's say for R in, and we'll create a list. So the first one is range 4. The second one is range 2, 5. And this really shows you how Python can handle different data types. So range is an object that we're just putting into a list. What am I up to? 12, 3, minus 3. Okay, so there's our list of values we're going to iterate over. I do a colon to say start a code block, and when I press return, you see Google automatically indents 4 spaces for me because it's expecting the code block there. And now I can print what R is, and then I can do another loop. I in R, which is the range, print I, and I don't want to end with a new line, I want to end with a space. And after the loop, then I'll print a new line. And let's see how that went. Yes, I didn't want an end of line there. And so there we go, pretty similar. Range 4 actually got printed as range 0, 4. Oh yes, and that's because up here I printed it as a literal. So you can see here I've got different ways of printing out what the range is, and this time I put a string literal because I've got the quotes around it. And down here I was storing it in a variable R equals, and then the value, and then printing out what R is. What else? I can even put it in curly braces in a format string. I've put it here commas on a multiple argument print statement. In this one I've said I want to end because I've got multiple values here. I don't want them separated too much, so I've said no separation, but I then put 2 spaces at the end to make it line up with the others. You can try just changing those values around and see what happens when you change them to see what effect those have. Oh yes, the other thing that I've done here is how do I put a new line into a string? So I could do a new line just by doing an empty print statement. Another thing you can do is you can put a \n into a string, and that means a new line. So the backslash says use n as a special character, and then it's going to be n for new line. So you can do others. You can do \t for tab. You \r for a cache return. Now here's a string that I've actually pressed return on to get my new line into it. And because it's going to be a string that can take new lines like that rather than having to use these \n, I've had to use these triple quotes. So you can use triple double quotes or triple single quotes, and then that says you can put a string with lots of new lines in it if you want, and it won't finish the line until it comes to another set of triple quotes of the same type. So all different ways of doing strings. Okay, and there's our solution. Let's have a look at the solution that was provided. And now this is getting a little bit more advanced, really not really something you'd normally see on the first absolute beginners session in Python. But what we're doing is, rather than put range 4 and range 2.5, we've just put the 4 and the 2.5 and the 3.14.4, and then we've created the range here. So we've got a range which is a function and it takes some arguments, but we don't know how many arguments there are going to be. So we've provided them all in a list. And so by putting an asterisk at the front, that means explode the list and put them in positions as they would appear. So 4 would appear as the first position, 2, 5, 2 appears in the first position, 5 in the second position. If there's 3, we have 3 will be the start, 14 will be the stop, and 4 will be the step, because that's the order those arguments are in range. So let's run that to see what it looks like. And yep, that's how they've printed out. And that looks good. And you can see here I've put in a width function 20 to say make that 20 characters wide, and then these all line up properly. So that looks good. So any questions in that? Is there anything there that you're not really sure? Okay, so I've called this tuple. So a tuple or a tuple is got these parentheses rather than a square brackets of a list. Really, they're interchangeable wherever you want. You can use them in either place for each other. Tuple, I find it's a read-only version of a list. So once you've got it, you can't change it. And in some cases, that's really good because it can stop some really obscure errors from creeping into your code. So my recommendation is use tuples wherever you can. But if you find you need to modify the values within the list, then you have to use a list. So the values within the sequence have to be changed, then you have to use a list, because that's an editable version of a sequence of numbers. But in this scenario, we could have used tuples or lists for either, and really tuples would have been better. I just use this to make it clear which are the otherwise it gets a bit confusing trying to read this code. You'll have all these parentheses. Okay, so we've been using some other functions now like range and print, but we can write our own functions. And in Python, if you want to write a function, you use def to define your function, then you give it your function name, and then in parentheses what parameters you want to pass through to the function. So in this case, we had a bit of code that we were looping through in a code block. That was a great way of repeating that use of code, but they were all in the one spot and just looped around it. But if you're using it from different spots in your program, then you need to define it into a function to be able to use it. So this is how it's been defined. It's exactly the same code as was there, and then we can call it just by putting in the function name and parentheses. So when it sees the parentheses, it knows that it's going to call the function, and whatever's in the parentheses get passed to the function as parameters. So let's run that, and yes, and it looks exactly the same. So we've done that for range 4 and for range 12.3 minus 1. Did you notice before we did range 12.3 that gives you no results, but 12.3 minus 1 will actually count down, and that's because the step defaults to +1, and going from 12 to 3 it's never going to get there if you go in steps of +1. So it doesn't happen at all. You're already past your finish value. So if you do want to step down from 12 to 3, you have to put in a step of -1 or a negative number. Okay, rewrite our loop from before, but this time calling the function. Okay. And what am I doing? I got to pass the range. Yep. So let's double ranges. And then I'll explode those arguments to fill up to explode all the arguments of range, and there's the results that we get as expected. So I think that's pretty similar to the solution. Yes, exactly the same. I just used a different variable name. And so notice how Jupyter Notebooks remembers tuple ranges and display range from before. So display range got defined in this notebook cell up here, and because that notebook cell has been run, it can then use that function in these later cells. If you hadn't run this cell, then the function would not have been defined and you wouldn't have been able to call it. Okay, functions don't need to have arguments, so let's have a function show time that'll find out what the current time is now and format it out. Now I'm going to use a standard Python library called datetime, and inside datetime library there's a class called datetime, and that class has a function called now. So to call it, I say the library name followed by dot, and then the class name followed by dot, and then the function name within that class, and then and that's going to return an object of type datetime, and then I'm going to call a function on that, string format time, to format it out. So you can see those dot is a way of calling functions. So I'll import datetime. That's because it's not imported by default. And then I can call it anywhere in my code. Now there's different ways of using this import function that can make this code a little bit shorter, but I'll just show you one for now. Okay, so when I call show time, it works out what the current time is and formats it out and prints it. So you can see there it is. We're running on Google Colab, which must be on UTC time. So the time there is 8:22:25 and that many microseconds. So if I run it again, you can see the time has changed. It's now 8:23:09 and this many microseconds. So let's have a look at some time zones, and we'll use the PyTZ library, which is not a standard Python library. So normally if you just installed vanilla Python, you'd have to install this this library, and the way you can do that was pip install PyTZ. However, Colab includes all the Python standard libraries plus those that are included in Anaconda, and Anaconda includes PyTZ. So for this one, I don't need to install it because it's already installed in Anaconda. So if you're looking at installing Python on your computer, you can choose python.org, or you can choose Anaconda as your source of Python. And the main difference is Anaconda comes with a lot of non-standard libraries built in, so you don't have to install them. Personally, I prefer not having those all those libraries because they can sometimes conflict with other libraries that I want to use, and I only want to install libraries that I'm using at a particular time, so that I know that I'm not accidentally getting stuff out of a different library or not getting a clash or an incompatibility. But people using data science, they'll often just use Anaconda because it's really a good set of libraries for the data science people, and they don't have to worry about installing all the other libraries every time they need them. All right, so we defined this function time zone regions, and what we want it to do is tell us all the regions that have got time zones. So the way it's doing that is going to use this PyTZ library, and there's a attribute in there called all time zones, and then we're going to extract some out of that. So let's have a look at what these look like. So I'm going to insert a code cell above. Now there's probably going to be quite a lot of them, so let's just look at the first 10. And of course I haven't imported Python, so I haven't run this one yet. So let's run it, and then I can use PyTZ. And this is what they look like. So a time zone has got a region name and then a time zone name within that region. So what we're trying to do, first of all, is find out all the regions. So we want to go through all of these. Here's a list, and they're all strings that are separated with a slash, the region before the time zone name. But some time zones don't have a slash. So like New Zealand, for example, it's just the region. There's only one time zone in the whole region, so they don't have a slash. So our code is going to go through all the time zones, look for a slash. If there's a slash, we're going to find out where the slash is in the name of the time zone, and we're going to slice up the string to just use the characters before the slash. So we did slicing in another session, but if you want me to go across slicing again, I can do a quick recap. And then we're going to add this into regions. Now regions is a set. So a set is like a list or a tuple, except that it can't have duplicates. So if you try adding the same time zone region twice, it'll just it'll only be once in there, and that's exactly what we want. We don't want Africa in there all these times. We can keep adding Africa in, but we only want one Africa to come out in the end. So that's one of the good reasons you use sets. Sets are not ordered, so not like a list or a tuple, so you don't know which way, which order they're going to be in. But we've sorted, we're calling the built-in function sorted here to sort our set, and storing that in a variable called sorted regions, and then we'll return that, and you can see that's going to return a list which has got square brackets and strings inside it. Alright, so define a function which takes one argument, a region, and returns the time zones in that region. So we've seen how to find the region of a time zone. Now we want to find that time zone and find anyone that has that region and tell us all the time zones that are in it. So let's define our function. So think about how you might want to do this. It takes one argument of the regions. Okay, so let's go time zones for region. And you see the Python really convention for function names. They use all lowercase for function names, and they use underscores between words. All right, we'll have a region, we'll just call it R. We can create a set. zones equals a set. We'll loop through all the time zones. And then we'll see if it starts, if the time zone starts with our region name. And we can actually use there's a Python function. I'll use the functions that we know. So do we know if are in time zone, then zones dot add time zone. Return zones. That'll do. So let's test that for region. Let's look in Australia. So that's looking pretty good. It's returning as a set, so you can see it's got the curly braces around it, and probably just in the order that they came in. Well, the order of a set's not really defined, so they happen to be alphabetical. That's just lucky. Let's have a look if we choose New Zealand. There, so it didn't quite work for New Zealand. We got New Zealand and New Zealand chat, whatever that is. So we're almost right with our solution. So let's have a look at the solution here, solution 8. So what we've done here, we've taken the problem around and worked out a function region for time zone rather than time zones for region. And we'll use that one function in two places. We'll do that. We'll use it in time zone regions, which is our function that we defined before, and we'll also use it in our new function. By using the same function in both places, we can guarantee that they're both going to give consistent data. And so we looked at the code here. It looks the region for a time zone takes everything up until the slash and returns it, or if there's no slash, it just returns it. And so that'll solve the problem with New Zealand and New Zealand chat, because we can just check if region for time zone equals region. Now the other thing we've done here is we've used list comprehension. And that basically takes these 4 lines and puts them all into one line. So you can do it using, in fact, that's for a set, and you can use set comprehension. So what it does, there's your loop for TZ in all time zones. You've got an if statement, if region for time zone TZ equals region, and you've got a what to do. In that situation, in that case, it's going to be adding it in. So whatever gets added in, you just put out in the front there. That's fairly advanced, so don't worry if you don't understand that. Feel free to write it all out like I've done here. But as you get better at Python, you'll start to understand this list comprehension or set comprehension as a quick way of writing 4 lines of code. So let's see how it worked with New Zealand. And yes, New Zealand, time zones for regions, just the one, New Zealand. Australia, you've still got the full list in Australia. ETC is an interesting one. This is ETC GMT. And UCT is the Greenwich Mean Time, Universal Coordinated Time. We print the time zone regions. We just check that still works because we've rewritten that with our new function with set comprehension, and that still works, and they're all in alphabetical order. And the other thing that we notice in the function, you see how we've put this triple quoted string as the first line of the function, and this is called a doc string. So whenever you write a function, you can put one of these doc strings in first, and then whenever you call help on that function, it will return that doc string. So other people who want to use your function will be able to call up help and see what they have to do to use your function. Okay, and you'll notice this quote, this first line here is a quote. It's got a hash sign. That's not included in the doc string. Just a warning here when you're using the etc time zones, they're a little bit confusing, but this is not a Python thing. This is really, in other languages, it's the same problem as in Java. So for example, Brisbane, which is 10 hours ahead of Greenwich Mean Time, if you want to specify that using etc, it's actually etc/GMT minus 10. Will give you the same time. All right, so let's have a look at help for the print function that to show what we've been using. Now I could have done print question mark and it would have come up over here in Ipython, or if you're using scripting Python console, then you use help print and it will come down here. So it says here we've got you can put values that you want printed, ... you can put several values that you want printed, and then you've got these things called named arguments that we've used, the default values. So new line is the default end value, space is the default separator, and so you can just change any of those if you want to. So let's write a function with named arguments with defaults. So for example, we want to write a function total seconds that we provide minutes and seconds, and it will return how many total seconds that is. Okay, let's run it and see what it looks like. So we can call it just by two numbers, 32, 15, and that's called using positional arguments, because it puts the arguments, it uses them by their position, their order that we supplied them. So we supplied 32 first and then 15 later, and so it's put 32 into minutes and 15 into seconds because that's the order they came. Now we could also provide them as named arguments. So we could say seconds equals 15, minutes equals 32, in which case the order doesn't matter, because it allows us to provide the seconds first. So in that case, when we're calling a function, we can call use that argument first by giving it a name. You can also mix. If you're going to mix them, you have to do all your positional arguments before you do all your named arguments. And so in this case, 32 for your minutes, and then there is only one named argument left, so seconds equals 15. So we didn't need to specify it, but if we did, it will still work. Okay, so let's expand that function to take 3 arguments. I'll give it the same name. Return hours times 3600 plus minutes times 60 plus seconds. And let's go on and we'll try calling it. One comma 5. So that should be 3900. So that's 3600 plus 300. Yep. Okay, let's have a look at the solution. Almost identical. Let's put some nice doc strings in there. It's got a few examples, so let's run the examples and see that they're all working. So we've provided 0 hours, Seconds, 15 minutes 32. Now we didn't even need to provide the hours because that defaults to 0. Yep, and using ordered or named arguments. Okay, so let's define a function now which converts temperature in Celsius to Fahrenheit. So let's define a function f that takes a value in Celsius and returns C times 1.8 plus 32. And let's have a look at what f at 100 is. So 100 degrees Celsius is 212 degrees Fahrenheit. So let's have a look at the solution here. We've used longer variable names, which is nice, and longer function names, so it's easier to understand what the function does. Bit of a docstring in there. And we'll look at some values. Let's run it and see how it converts. So 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. 100 degrees Celsius is 212 degrees Fahrenheit. And minus 40 degrees Celsius is minus 40 degrees Fahrenheit, coincidentally. Okay, so that worked for Celsius. Now we want to define a function which converts temperature in Celsius or Rankine to Fahrenheit. So we could do that. Let's just C equals none or R equals none. So none is no value, not provided, and because we want both of them to be optional, we have to give them a default value. If we didn't give them a default value, then that would be a compulsory argument. So let's say if C is not none, in fact you can just say, no, we can't do that. If C is not none, then we return what we did before, which is C times 1.8 plus 32. Else, if R is not none, return R minus 459.67. So we've still got a case that we haven't provided for. So if they haven't provided anything, then let's just return nothing. Okay, and let's see what Fahrenheit temperature of 460 is. It's 0.33 degrees Celsius, Fahrenheit. Okay, so we've defined a function here. We haven't really looked at every case because they could have provided Celsius and Rankine, and what do we do in that case? And we've looked at just when they provided nothing. And yeah, so let's have a look at the solution here. We could have done a lot more if statements. So if Celsius is none, then we check for the Rankine. If Rankine is none, then we've got an error. I just returned none up here, but you can raise a value error, and that's what like throws an exception, so that they'll every time they try to run their code, if they don't provide either of those, then they'll know they're doing something wrong. So otherwise they can do the formula for Rankine, because Rankine is not none for this else, and this else here is for the Celsius one. So in this case Celsius is not none. So in this case, if Rankine is none, it's all good. They provided a Celsius, they haven't provided a Rankine, we can return that value. But if they provide both, then we've got another error. You must provide exactly one of Celsius or Rankine, not both. So these value errors, if we try to run them, so let's just run this code, and that worked, and they're all converting, and it's showing Rankine to Fahrenheit, Celsius to Fahrenheit, and we're seeing a value error. And the reason we're getting that if there was we've put them in a try except. So try means we think there might be an error, and so we're going to catch it. So do this except for the case where there's an error, in which case do this, in which case it prints there was a problem. Alright, so let's have a look what would happen if we didn't have that try except in there. And I'm just going to put another code cell in here, and let's grab this bit of code. Get the tabs right and run it. And so the first bit runs okay, but then when it gets to this line here, it actually throws the value error and it breaks. So if you were running this, if it's stupid a notebook, you're trying to run it right from the start all the way to the end, and it got to here, it would actually stop and go, no, we've got an error. You've done something wrong. So if you don't want it to stop, you have to catch it and put in place something that's going to happen in the case that the error occurs. And all we want to do is say there was a problem and print out what the problem was, but we don't want it to stop calculating. Okay, now you'll see that both of these lines would create an error, but because that one created an error, it jumped down to here and said that, and so this one didn't get run. So if you wanted to make it run every line, you have to put a try except around every line. And then you can see the two problems at the bottom. So the first one says both were provided, which is an error, and the second one says neither were provided, which is also an error. Alright, so this tries and accepts probably a bit too advanced for first day Python, but just letting you know that they're there so that you, if you come across them, you'll know what they sort of know what they're doing. And if you really need to catch some sort of error that's happening, there's an option that's open to you. Okay, whizzing through all the data types, here's one called a dictionary in Python. So we've done lists, we've done tuples, we've done sets. So dictionaries, it stores key value pairs. And it's called a dictionary because a dictionary, you look up something, you look up a word and find a meaning. So that's the key is the word, the meaning is the value. And that's how you use dictionaries in Python. You have a key that you look up. So for example, you define it with curly braces, and you have your key here. So the number 10 is a key, and the word 10 is the value. We've got keys of numbers. Here's a key which is actually a word, and this is a value which is a number. So they can be the values can be any type of value. The keys, they have to be what's called a hashable value, which basically means an immutable value. So this is a key is an area where you could use a tuple, but you can't use a list, for example, because lists you can are mutable, you can edit them, but you can't edit tuples. You can loop through all the keys and print them out. This is really just a quick introduction to dictionaries. So you can see that's how you call values in a dictionary, and you can look at the length of the dictionary. And the reason we're looking at dictionaries here is because we're trying to expand our Fahrenheit function. We're looking at first of all, we'll look at a different way of writing it. Remember before we had the different keyword arguments, we had Celsius and Rankine. Now we can put all of those into one variable called keyword args, and that can be any variable name you like. But the important thing here is it's got these two asterisks at the beginning, which is ready to explode key value pairs out. And when you, so if you remember before, we were using a bunch of numbers in a list, and we expanded them out using the asterisk when we were calling the function. When you're actually the function, you can actually compact them back into a list, or in this case a dictionary. If you use double star, you get a dictionary. If you use single star, you get a list. And so it'll give them all as named arguments, and this makes the coding a little bit easier, because it's easier to look at all the different things. For example, we want to make sure they provide one argument. Now all we've got to do is go, the length of the keyword arguments equals 1, rather than going, have they given us a Celsius, have they given us a Rankine, have they given us a Celsius and a Rankine. And then to get the values out, we can look at what the keys are. So we can see the key is Celsius, so they're basically our argument names from before. We can throw an error if they use the wrong key. Unfortunately, your Python environment's not going to be able to flag if you use the wrong key when you're writing the code. If they've defined a function this way, it'll only happen at runtime, because that's when it actually checks to see what the key is. And it's your code, not Python, that's checking the key. So you have to be a little bit more careful in that. But we can see we've got fewer lines of code here. Let's run it and see. It gives us the same answer as before. So it's equivalent code. But now we want to add a third possible argument. We want to take Kelvin temperatures in there. And that's going to be a lot easier, because I can just take that original function. The length of the keyword argument still has to be 1. We can have a key of Celsius, a key of Rankine, and we just add in one more. Kelvin. And it's just going to be value times 1.8 plus 459.67. I think that's supposed to be minus, even though it says plus there. Kelvin times 1.8. Yeah, that's got to be minus. We can change our error message. And we can run that to define it. And let's have a look. We've got some examples down below. Well, let's compare the code. It's all the same. Yeah, I used minus there, so I better fix the original notebook to say minus. And it all prints out nicely. Okay, so there was a fair bit there. I don't expect you all to have made it all the way to the end. For the first timers, that was, I hope you've learnt something, and you've got into Python and you've worked out how to experiment in Python using Google Notebooks, Google Colab, or Jupyter Notebooks. For the people who've used Python before, maybe you've picked up some more things on how to define functions, or some of the things you can do with sets or list comprehension or set comprehension. Next week we're going to be doing an exercise. You won't be actually having to type any Python code, because it's going to be complicated enough as it is, which is we're going to write a driver in Python that will enable us to print to Excel spreadsheets. So you know We've got print to PDF is a common thing in operating systems these days. We're going to write our own print to Excel functionality, and it's going to be running in Python. So you'll learn about networking and sockets and ports, clients and servers, and also how to create Excel files from data, and even a little bit of command line shell scripting to on how to print things. So yeah, I'll provide all the code, and your challenge is to be able to run it as you follow along in the video session. So I hope you enjoyed tonight. If you like it, please click on the subscribe or the like, and in 2 weeks' time, Arun will be taking the session, and he'll be doing machine learning. So if that's more the sort of thing you're interested in, then that'll be a good session for you to catch up on. Thank you and bye.